You stand on solid ground, you feel the weight of gravity, you trust the bedrock beneath your feet. Since childhood, we've been taught that the Earth is a predictable system. Geology is an established science. Rocks are just rocks. But what if that foundational trust is a lie? What if the planet we inhabit is less of a solid sphere and more of a giant, unpredictable machine with glitches in its operating system? Forget volcanoes and earthquakes. Those are merely the predictable tantrums of a hot-tempered world. We're talking about anomalies that defy classification, events that make scientists scratch their heads and quietly close their textbooks. What exactly is a geological puzzle? It's simple. It's an occurrence on or within the Earth that cannot be explained by any existing, peer-reviewed, accepted scientific principle. Think gravity-defying rivers. Think rocks that move themselves across dry lake beds. Think sound that exists only to the human ear and no instrument can detect. They are the geological equivalent of a paradox. What if the Earth beneath our feet holds secrets stranger than any science fiction? Imagine ancient rivers flowing underground, defying gravity, or colossal crystals growing in impossible caverns. Prepare to have your understanding of our planet shattered as we uncover Earth's most inexplicable geological puzzles. Today, we begin our journey by looking at the things that literally move without moving. We'll investigate the legendary sailing stones of Death Valley, rocks the size of small refrigerators that slide hundreds of yards across a flat surface as if driven by a ghost. Then, we dive into the mystery of the Taos hum, an acoustic anomaly so persistent that it drove some residents to despair. Yet it remains completely undetectable to the most sensitive seismic and acoustic equipment. It's a sound that exists only in defiance of physics. But those are just surface tensions. In later sections, we'll descend into the deep earth to explore phenomena like dragon's breath, vents, and caves that literally sing, before we even begin to touch the theories that link these puzzles to extraterrestrial forces. The question isn't whether science can explain these events. The question is, why hasn't it? Stay with us. Your solid ground is about to shift. We begin where logic ends, the cracked, desolate floor of Racetrack Playa in California's Death Valley. This is one of the flattest places on Earth, and it hosts one of its greatest kinetic mysteries, the sailing stones. Imagine rocks, some weighing over 700 pounds, the size of a small refrigerator, moving hundreds of yards across this dry lake bed, seemingly under their own power. No human intervention, no animals, just a rock, leaving a solitary, impossible track in the mud behind it. For decades, these tracks were a riddle set in stone, or rather, set by stone. They turn, they reverse, they race each other, sometimes moving parallel for a stretch before veering off on impossible trajectories. Early theories ranged from magnetic fields to secret vortexes. Scientists even tried manually placing GPS trackers on the stones, a project that took years and was often met with failure. Why? Because the rocks often didn't move when they were being watched. They behaved like shy secrets. The accepted, mainstream explanation finally arrived only a few years ago, a very specific cocktail of rare weather conditions. A shallow layer of water freezes overnight, creating thin, expansive sheets of ice around the base of the rocks. Then a light wind, not a gale but just enough, pushes the sheets of ice and the rocks along with them, leaving the signature tracks in the soft mud underneath. It sounds neat, right? A solved puzzle, but even this explanation leaves questions. Why do some rocks move while others nearby do not? Why do the tracks sometimes suggest movements that defy the simple physics of wind? The mystery may be partially resolved, but the feeling you get standing there, the sense of something unseen guiding the stone, that remains unexplained. From a visible moving object to an invisible sound. Our next enigma takes us to the quiet, spiritual town of Taos, New Mexico, home to the phenomenon known globally as the Taos hum. For years, a small percentage of Taos residents, roughly 2%, have reported hearing a persistent, low-frequency humming or buzzing sound. It's often described as sounding like a distant diesel engine, or maybe a truck idling outside. But here's the bizarre contradiction. The hum is audible to people, but not to instruments. Scientific teams have descended on Taos, armed with sensitive seismographs, magnetic field detectors, and acoustic arrays. They measured everything from the power lines to traffic to underground pipes. The conclusion? Nothing. The instruments registered silence, even while the residents standing right beside them were complaining of the disruptive noise. This isn't just irritating, it's debilitating. Sufferers report symptoms ranging from nausea and dizziness to sleeplessness and elevated stress. Are they hearing something genuinely physical that operates outside the known range of our technology? Or is the anomaly internal, a rare collective neurological condition triggered by an unknown environmental factor? Scientists suggest everything from spontaneous otoacoustic emissions, sounds generated by the ear itself, to extremely low-frequency radio waves. But until a device can definitively capture this unheard sound, the Taos hum remains a genuine, anxiety-inducing mystery that exists in the gray area between the physical and the neurological. Our final stop in this dynamic section is one that appeals directly to our senses, but still defies geological convention: the ringing rocks of Pennsylvania. If you walk into this seemingly ordinary field of boulders, pick up a smaller hard rock, and strike one of the large gray boulders, you don't hear a dull thud. You hear a clear, metallic bell-like tone, sometimes a distinct pitch. It's music played by geology. What's the secret? These rocks, scientifically termed diabase, have a high density and are virtually free of iron, which is unusual for this type of rock. Their internal structure is highly compressed, and their joints are tight, but those properties alone shouldn't make them sound like a percussion instrument. The puzzle isn't just that they ring, but why only here? Other similar rock formations exist globally, but none resonate with the same consistent musical quality. Scientists speculate that the extremely tight internal grain structure, combined with the way they were exposed to weathering, creates a natural resonator. Whether it's the invisible force moving the rocks in Death Valley, the phantom sound in Taos, or the singing stones of Pennsylvania, these are not ordinary formations. They are Earth's glitches, moments where the clock stops and the rules change. And if these surface anomalies are this bizarre, wait until we descend into the deep Earth. If the surface of our world is home to mysteries of movement and sound, then what happens when we drill down? When we leave the sunlight and enter the realm of the deep, the puzzles become less about subtle movements and more about sudden, terrifying voids. Our planet is defined by tectonic plates and the predictable stresses of seismic activity. We understand earthquakes, we track them, but sometimes the ground simply decides to change its mind. We call this terrifying phenomenon earth breaths. Imagine an entire field or a section of a road suddenly bulging upwards, a slow, silent inhalation. Then, just as mysteriously, it collapses back down, or even worse, it swallows itself entirely, forming a colossal sinkhole. The defining feature of an earth breath is the lack of a clear seismic cause. There's no fault line slipping, no volcanic magma pocket rising. It's localized ground failure on a grand scale. Experts are often left hypothesizing about rapidly shifting groundwater tables or the sudden dissolution of underground soluble rock like limestone. But these explanations struggle to account for the speed and the sheer localized power of the event. Why did the ground heave there? Why did it collapse now without the usual warnings? It's as if the Earth itself is contracting and expanding its inner lungs, indifferent to the structures on its skin. These events are not always violent, but they are always inexplicable in the moment. They are a profound reminder that we live on a skin of rock stretched over something volatile, something we barely understand. Deeper still, where heat meets rock and volatile gases escape, we find another mystery: dragon's breath vents. This isn't just steam or the usual sulfuric fumes from a predictable volcanic vent. These are sudden, unexpected releases of mysterious gas compositions in locations that are often geologically quiescent, quiet. In remote, inaccessible areas, the high mountains of Central Asia, the isolated deserts of Africa, scientists have recorded gas emissions that contain chemical signatures that simply don't match the local geology. We're talking about unusual ratios of noble gases like helium-3, or unexpected concentrations of highly volatile compounds through. Where is this gas coming from? If it's from magma deep in the Earth's mantle, why is it escaping through this particular, isolated crack in the crust, miles from the nearest fault line or volcano? Some propose deep pockets of primordial gas, remnants from Earth's formation, finally finding a pathway out. The unsettling part is the lack of context. These vents pop up, they emit for a time, and then they vanish, sealing themselves up again like a secret being hidden. They are literally the Earth sighing. But the composition of that breath suggests something is churning in its gut that our models have yet to account for. Finally, we return to sound. But this is not the localized hum of Taos. This is natural music. We are in the realm of the singing caves, caverns that produce harmonic musical notes without the presence of strong wind or flowing water. In locations like the Wind Caves in South Dakota, or specific phreatic, water-formed caves globally, explorers have reported hearing distinct pitches, sometimes even a recognizable scale, emanating from the rock formations themselves. It's not the sound of dripping water echoing. It's a genuine, resonant tone. The scientific theory points to standing waves, acoustic resonances generated by the unique dimensions and shapes of the cave chamber. The cave acts like a gigantic organ pipe, with minor air pressure changes or subtle tremors causing the air inside to vibrate at fixed frequencies. But the frequency of these musical events and the purity of the notes still confound researchers. To produce such clear harmonics requires near-perfect conditions and a steady energy source. What is the subtle energy source that causes the Earth to play its own organ? We are hearing the Earth's natural acoustics, but the source of the vibration remains one of its deepest secrets. These deep Earth whispers prove that beneath the surface, the rules of stability, chemistry, and sound are being rewritten. But could the source of these anomalies be even farther away than the center of the Earth? Next, we look up and explore the controversial possibility of cosmic connections. We've seen rocks move themselves and gases escape from nowhere. But now, we encounter anomalies that don't just defy geology, they smirk at chemistry and laugh in the face of thermodynamics. Our next stop is beneath the Nika Mountains of Mexico, home to a discovery so staggering it looks like a scene from another planet. The giant crystal cave. Discovered by miners, this chamber holds some of the largest natural crystals ever found. Imagine gypsum crystals, perfectly formed, stretching up to 36 feet long and weighing 55 tons. You could park a bus on one of them. The chemical composition is just water and gypsum, simple enough. The problem is the scale and the speed of the growth. For crystals to reach this size, they need two things: an incredibly specific, stable temperature, in this case around 58 degrees Celsius, and an equally stable, saturated mineral solution, for tens of thousands, perhaps hundreds of thousands of years. Geologically speaking, the cave is young. Scientists have determined the crystals grew rapidly within a relatively small geological window, only about 500,000 years. That's still a long time, but for crystals of this magnitude, it pushes the boundaries of known growth rates. It suggests an almost perfectly isolated environment, maintained with laboratory-like precision by the planet's natural systems. The question is, what planetary mechanism maintained that stable temperature and chemical saturation for 500,000 years with such absolute fidelity? This isn't just a natural occurrence. It's a monumental feat of natural engineering that defies the chaotic nature of subterranean thermodynamics. Now let's move from solid matter to invisible forces. The magnetic field is our planet's great invisible shield, generated by the churning liquid iron in the outer core. It's what guides navigation and protects us from solar radiation. We know how it works, mostly. But in specific locations across the globe, we encounter rogue magnetic fields. Intensely powerful, localized magnetic anomalies that cannot be explained by the current global magnetic model or the local rock composition. The most famous example is the Kursk magnetic anomaly in Russia, located near the city of Kursk. It is, quite simply, the largest magnetic anomaly on Earth. While the presence of massive iron deposits explains some of the field's strength, the sheer magnitude of the magnetic field generated by this region still significantly exceeds what the mass and composition of the ore should produce. This magnetic paradox has led to speculation. Is there a deeper, unknown mass of metallic ore that defies known geological formation processes? Or, and this is where we touch on the truly inexplicable, is the anomaly being powered by an unknown energy source that is somehow interacting with the Earth's core? Remember the Tao's hum, a sound with no physical source? Now imagine a magnetic field whose power source is equally baffling. These anomalies challenge our basic understanding of electromagnetism and material density within the Earth's crust. They force us to ask, is the core communicating with the surface in ways we haven't recognized? Are there fundamental, localized energy dynamics happening beneath our feet that our instruments simply misinterpret? We've seen the impossible size and the inexplicable power. If our own planet is capable of generating such contradictions, perhaps we need to look beyond terrestrial science entirely. Next, we step into the ultimate frontier, cosmic connections. We've now established that many of Earth's greatest puzzles, the Tao's hum, the rogue magnetic fields, the impossible crystal growth, cannot be fully reconciled using the standard rulebook of terrestrial science. When logic is exhausted, where do you turn? For many researchers operating on the fringes, the answer is simple. You look up. The idea that extraterrestrial or cosmic forces could influence local geological anomalies sounds like science fiction, perhaps even irresponsible speculation. But consider this. The formation of our planet, the source of its water, the very elements that make up its core, all came from space. The Earth is not a closed system. Every time a major cosmic event occurs, a gamma-ray burst, a solar flare, a comet impact, our planet registers it. If large-scale cosmic events can trigger extinction-level volcanism, is it truly a leap to suggest that subtler, localized energy sources could be influenced by external forces? The theories are varied and admittedly controversial. One proposes that some magnetic anomalies, like the extreme power seen at the Kursk anomaly, are not powered by underground iron, but by the gravitational or electromagnetic shadow of massive passing cosmic objects, perhaps brown dwarfs or undiscovered planetary bodies. Another, more intriguing theory focuses on unusual mineral composition. In certain areas associated with long-term geological instability or unexplained energy releases, researchers claim to find unique isotopic signatures, ratios of elements that simply do not form under normal terrestrial conditions. These signatures, some argue, hint at materials delivered by meteorites, or perhaps even engineered at the atomic level. This is where the lines blur. Could the consistent musical resonance of the singing caves be amplified by an external, ultra-low-frequency radio signal, perhaps one natural to the solar system, or perhaps not? The hypothesis here is that these anomalies aren't caused by aliens, but that their energy profile or material composition is linked to non-terrestrial sources. Now for the critical balance. Mainstream science, by its very nature, demands empirical, repeatable evidence. When faced with theories that rely on unseen cosmic influences or unverified material compositions, they have a professional obligation to dismiss them. And frankly, many of these fringe ideas are easily explained away by human error, misinterpretation of data, or wishful thinking. The Tao's hum, for example, is more often attributed to industrial noise or neurological factors than to alien transmissions. The sailing stones are far more likely to be moved by ice and wind than by a secret energy field. This dismissal isn't malice, it's methodology. Yet for us, the audience, and for those who seek the truly unknown, the questions raised by the cosmic theories are vital. They force us out of our comfortable terrestrial box. Just because a theory is dismissed today doesn't mean it's irrelevant tomorrow. Do you believe you understand the forces that shape our planet? Think again. Join us on an unprecedented journey to the farthest corners of the Earth, where we'll encounter geological phenomena so bizarre, so confounding, they challenge the very foundations of scientific thought. Can you unravel the secrets behind these truly unexplained geological puzzles? Perhaps the answers lie not beneath the crust, but out in the vast, silent expanse of the cosmos. The Earth is still reacting to forces unknown. The question is, are we ready to admit it? We started by challenging the stability of the ground beneath our feet, and what we found was a planet far more mysterious than we imagined. We encountered rocks that race across the desert with no engine, a pervasive sound that technology refuses to acknowledge, and subterranean heaves that prove the Earth breathes on its own terms. We've seen crystals grow to impossible sizes, defying the pace of time, and localized magnetic fields that contradict our core understanding of planetary physics. These aren't just minor data points. They are massive, gaping holes in our scientific map. The unsettling truth is this: despite the thousands of instruments pointed at the Earth, seismographs, magnetometers, spectrometers, these phenomena persist. They are real, they are measured, yet they remain stubbornly inexplicable. They force us to accept that our most comprehensive models of the planet are inherently incomplete. So what secrets does the Earth still hold? Is the Tao's hum a signal? Do the rogue magnetic fields hint at undiscovered physics? The journey to discovery is not over. It has only just begun. The answers require a new generation of geologists, physicists, and thinkers who are willing to look beyond the textbook. Do you know of a local anomaly that defies explanation? Do you have a theory that bridges the gap between the known and the unknown? We want to hear it. Share your knowledge, your theories, and your questions about these truly unexplained geological puzzles in the comments below. Subscribe to join us as we continue to investigate the glitches in reality. Thank you for watching.